Okay, so our next speaker is Edwin Chang, automated transformation of digital circuits to Minesweeper boards.
Hi, I'm Edwin, and I'm a second-year computing student, and this is my project for PyRTLSweeper. So back in spring quarter, I took this amazing class taught by now Professor Zach Sisko about some very unconventional ways to prove hardware and software. And as with any CCS course, there was a very difficult final project, which was to do pretty much whatever I wanted. So of course I had no idea what to do until I came across this very serious paper from a very serious conference about building Minesweeper in Minesweeper. Now I'm guessing most of you have played Minesweeper before. So you get this board, and there's a bunch of mines scattered around the board. And every number tells you how many of the surrounding 8 cells have mines in them. So you get this board, and your goal is to clear all the safe cells and then flag all the mines until the entire board is clear. Now consider this board. There's exactly 2 ways for the mines to be laid out on this board. Either on the left side of each pair or on the right side of each pair. And if we place one of them, it determines all the others. We can extend this pattern for as long as we want, and if we place one on one side, it determines all the other lines going to the other side. So it's a little bit like a wire, right? Our wire can turn one way, or the other, or split into 2 directions, or even cross over another wire. And these 2 wires are completely independent of each other. So what this paper did was it took 2 of these wires, and then combine them into this really big logic gate that can do 3 operations at once. And then it copy-pasted this a bunch of times to add numbers together. And then it copy-pasted this a bunch of times on this giant Minesweeper board to count how many of the surrounding giant cells have mines in them. Hence Minesweeper in Minesweeper. Now I thought this was pretty cool, but surely we can take this further, right? So back in the winter quarter, I learned about PyRTL, which is an amazing library made here at UCSB for writing digital circuits in Python. So what if we could take PyRTL circuits and convert them into Minesweeper boards? So it turns out you can actually make any digital logic using just 2 gates, NOT gates and AND gates. A NOT gate converts whatever value you give it, while an AND gate only turns on if both of its inputs are on. And luckily, PyRTL has some very convenient methods for converting any circuit into only NOT gates and AND gates. So I designed this NOT gate in Minesweeper, and then I took that really big logic gate from before and I shrunk it down to this AND gate. And then the problem was, how do I take these gates and then put them on the board in a nice way? And the answer was to just stack them all up vertically, so the inputs are on top, followed by the gates, and then the outputs. And then just have all the inputs come from the left, outputs go to the right, and then loop all the wires around. So I wrote an entire script to do this, and it took this circuit, which is an OR gate, and made this board. This is an XOR gate, except this one doesn't actually work because there was a bug in PyRTL, but I fixed that. Now this is cool and all, but this board's kind of big and ugly. It would be cool if we could get rid of all that spacing between the wires so it looked like this. There's a problem with this, which is that when I was doing this, the school year was ending, and I was lazy and tired. So I went on vacation to Atlanta. I had a very relaxing time in Atlanta. I went to the museums, I visited Georgia Tech, I worked at Google. Then I came back, I remembered I was still working on this project, and I wanted to get rid of the spacing between the wires. So in order to do that, I had to take the AND gate and then shrink it down into this. And then I also had to shrink down the NOT gate, except that wasn't possible, so instead I just staggered every other NOT gate. And then I rewrote my entire script and produced this thing. This is the final product. This is OR, this is XOR, and this is a bigger circuit with 2 inputs, 2 outputs. This thing is like 1,000 lines in it or something. There's some stuff I did not get to implement in this project, like registers in memory. That's because I tried to think about like how do I store state inside of a Minesweeper board, and it just kind of made my brain hurt. So I didn't do that. And for the real world applications, yeah, if anyone finds any, please let me know. I want to give a special thanks to Zach for letting me do this project. Kirby 703, who wrote the original paper that inspired this, all the other authors of previous papers, and everyone in CCS for listening to my idea. I want to thank you all for listening, and if you want to learn more, you can scan this QR code, and I will now take questions, comments, and job offers.
More difficult if you instead reverse engineering by creating an application that takes the inputs of Minesweeper boards and outputs the computer program. Do you think this is more difficult?
Yeah, that would be very difficult. It might be possible, though. Who knows?
I was wondering, remember how it would be difficult to implement like registers in memory? Could you not, for example, using logic gates, then just like reconstruct computer architecture with Minesweeper?
Yeah, you could. Yeah.
Yeah, just do that.
A little bit difficult.
That hard.
You have the pictures of Minecraft. Can you do a Minesweeper in Minecraft?
That's definitely been done already, a lot of times.
No other questions? Thank you. Edwin again?